In today's session, we're going to be placing fractions on a number line, but this time we're going to be working with mixed numbers. So this is going to be those fractions that have a whole number and a fraction alongside. So it means that we're going to be going beyond the number 1. So before we move on to this, let's remind ourselves of the strategies we learned in the last session, because these are going to really help us in today's session. So when we were trying to identify a fraction on a number line, the first step was to work out how many equal parts the number line had been split into. So looking at this number line, we can see that we're working with this as a whole between 0 and 1, and we're splitting it into 7 parts. So now we know that it's split into 7 parts. The question is, what does each interval on the number line represent? Well, if we split the whole thing into 7 parts, we've broken it into 7. So our denominator is going to be saying 1 split into 7 equal parts. So the denominator is 7. And each of those parts is going to be one of those 7 parts. So 1/7 for each step on this number line. Now we've worked out that on this number line, each interval is worth 1/7. We can simply count up in 7. So 1/7, 2/7, 3/7, 4/7, 5/7, 6/7. 7/7 meaning we've got the whole, so we can change that as number 1. So let's remember those 3 steps we have. Look at your number line and work out how many equal parts it's been split into. Use that information to find your denominator and work out the value of each interval on that number line. And finally, apply that understanding, that knowledge of counting on in fractions to label each interval with the actual fraction that you're working with. So in today's session, as we said at the beginning, we're going to be working with those number lines again. This time we're going to be focusing on number lines that extend beyond 1. So we're going to have different whole numbers on there, not just 0 and 1. And that means that we're going to be working with mixed fractions. So those whole numbers with fractions next to them to say it's between 2 different whole numbers. And opening up our textbook, we can see our first problem is relating to Jamila, Jamie and Lee. And they are talking about their ages, and they're using mixed numbers for this. So we can see that Jamila is saying that she's 7 1/4, so 7 whole years and 1/4 of a year. We've got Jamie saying that she is 8 1/4, so 8 whole years and 1/4 of a year. And Lee is 7 3/4, which is 7 whole years and 3/4 of a year. So we can see we've got our whole numbers and our fractions to make those mixed numbers that we were talking about at the beginning. Now for question 1a, we're asking, where will Lee's age go onto this age chart? We can see that we've already got Jamila and Jamie labelled with their arrows. So whereabouts would Lee go on that number line? Now, in order to answer this question, be thinking about yesterday's work where we were working out what the value of each interval would be and using that to help us count. So if we look at this number line, what is the fraction that each interval is going to show, and how can we use that to label Lee on this chart, just as Jamila and Jamie have already been done. And once you've done that, we can look at that chart and we'll be able to identify who is the oldest of the 3 children. And what is it about that number line that shows you that that person is older than another person? Once we've managed to label all 3 of them on the number line, our question for 1b is, how much older than Jamila is Lee? So this will be the idea that now you know where they are on the number line, we're going to be looking at counting on in those fractions between one person and another to find out how much older one is than the other. So now what I'd like you to do is pause the video and I'd like you to work out those 2 questions. So question 1a, where will Lee's age go onto this age chart? And then using that information, you can work out who is the oldest of the 3 children. And then question 1b, how much older than Jamila is Lee? So pause the video and work those out, and then join me when we're ready to discuss our strategies. So let's take a look at question 1a and see whether we can work out the strategy to solve this. So let's start with the first part. Where will Lee's age go on this age chart? Now we can see that at the moment we've got Jamila and Jamie already labelled on there. And I've got 2 choices now, because I'm going to use the method that I used in our previous lesson, where I'm going to work out how many intervals this is showing. And that's going to help me work out the denominator and then allow me to work out the fractions. Now, I've got 2 choices here. I can start at 5 and count up to 10 and work out the number of intervals. Or I can use a more efficient strategy, which is looking at the number 7 to the number 8. And I can work out how many jumps that I need to go from the 7 to the 8 to work out that first part of the problem. So we can see that between the number 7 and the number 8, I've got my 4 jumps. So 1, 2, 3, and 4. And this shows me that the denominator I'm going to be working with is 4. So I'm going to be working in quarters. And each one of those jumps is going to be worth one of those quarters. So I've used that knowledge just to label the intervals that I'm interested with at the moment. So I know that Jamila is after 7 and Jamie is after 8. So I'm not worrying so much about my 6s and my 9s. So I've simply counted on in 1 quarter. So 7, 7 and 1 quarters, 7 and 2 quarters, 7 and 3 quarters, 8. 8 and 1 quarter, because my next one would be 8 and 2 quarters, then 8 and 3 quarters until I get to 9, and so on. So I've simply labelled that, not worrying about where my people are labelled and highlighted at the moment. I just want to get those fractions down so I can make sure that I'm working with the right numbers. As if I've made a mistake on here, and for example I was counting in fifths, I would have 7 and 1/5, 7 and 2/5, 7 and 3/5, 8. I know that 8 would have to be 7 and 5/5, so I'm missing 4/5 there. So by labelling each interval, it's going to highlight any mistakes I've made simply with my counting, not realising that I had 4 jumps and thinking it was a different number. So now what I've managed to do is just identify the fractions for Jamila and Jamie. So we can see that Jamila is 7 and 1 quarter, and Jamie is 8 and 1 quarter. And if we go back to that original question, we can see that Jamila is saying that she's 7 and 1 quarter years old, and Jamie is saying that she's 8 and 1 quarter. So now this means I can use that information to help me find where Lee should go. And Lee is telling me that he's 7 and 3 quarters. I can simply draw my arrow just here and write down that Lee should go in this spot. So nice and simple so far. I've simply followed my strategy of looking at how many intervals are in a whole, so between 7 and 8 in this instance, and worked out there's 4. That tells me that's my denominator, so I'm working in quarters. Each jump is worth one of those quarters, and I've used that counting method of 7, 7 and 1 quarter, 7 and 2 quarters, 7 and 3 quarters, 7 and 4 quarters, or 8, 8 and 1 quarter, 8 and 2 quarters, 8 and 3 quarters, 8 and 4 quarters, or 9. And then labelling those, I've been able to identify where Lee should be as someone who is 7 and 3 quarters years old. And by placing those names on my number line, it's quite easy to see that the oldest person there is Jamie, the youngest person is Jamila, and the middle one is Lee. So the oldest one is Jamie at 8 and 1 quarter years old. So now we've looked at the strategy we used for 1A, let's move on to 1B. And our question here is, how much older is Jamila than Lee? Now this is where the fact that we've got our labels already done makes this job an awful lot easier for us. Now the first point to look at this is, who am I actually talking about? Well, in this case it's Jamila and Lee, so we can get rid of Jamie straight away. Now we're going to work out the age of Jamila and Lee. So we know that Jamila is 7 and 1 quarter years old, whereas Lee is 7 and 3 quarters years old. And nice and easily I've labelled those, and I've also labelled any of the intervals that are in the middle. So it doesn't matter what the fraction is, labelling every interval is the thing that's going to help me and prevent me from making a silly mistake. So jumping from 7 and 1 quarter to 7 and 2 quarters is a jump of 1 quarter. And then we can make one more jump of 1 quarter. And the idea is I'll carry on making these jumps and carry on labelling these jumps until I get to where I need to be, which in this case is Lee at 7 and 3 quarters. And now we can see that I've got Jamila, and I've counted 1 quarter and then 1 quarter, or 1 quarter and 2 quarters to get to Lee. So when we look at how much older than Jamila is than Lee, we can see that she is 2 quarters of a year older. So let's have a little recap of the way that we've done this today. So we've been looking at placing mixed numbers, so those whole numbers and those fractions put together, onto a number line, which means we've been looking at number lines greater than 1. So our first step is to look at how many parts the number line has been split into, and we're going to focus specifically on between 2 whole numbers. So in the case of the example below, we can see that we've got the numbers 2 and 3, and we're looking at how many intervals are between those. So if the number line is longer, so it goes from 2 to 7, for example, just choose between two whole numbers, so 2 and 3, 3 and 4, whatever it is. How many parts has it been split into? Because this is what's going to let you know what that denominator is. So on this one, we can see that it's split into 1, 2, 3, 4, 5, 6, 7 parts. Because this will make it so we can answer the second part of this. What does each interval on the number line represent? Well, if I've split it into 7 parts, then each jump or interval is worth 1/7. So when I'm looking at this now, I know that I'm working in 1/7, and I'm going to be able to learn how to count in those numbers to answer my next question, which is what fraction is each interval on the number line. And in this case, we can see that each one is 1/7. So we've got 2 and 1/7, and 2/7, and 3/7, and 4/7, and 5/7, and 6/7, 3. Notice how I haven't put a whole number. I'm still working with my non-unit fractions on this and my unit fractions. The next stage is where those two big numbers, those two whole numbers come into it. Because this is the real difference between yesterday's learning and today's learning, is this fourth step. And for mixed fractions, what two whole numbers is the fraction between? So in this case, we can see that 1/7, 2/7, 3/7, and so on are between the numbers 2 and 3. So I'm actually not working with 1/7, I'm working with 2 and 1/7, 2 and 2/7. And this will allow me to label, to identify, and to do lots and lots of different things with this number line, but to be really clear on what the number is going to be. So now it's time for you to pause the video and to continue with the textbook and give those questions a go before you move on to the independent activities in your workbooks. So remember these 4 steps, come back to them whenever you feel like you're getting stuck, and I'm sure that you'll do phenomenally well on these questions. So good luck, and I look forward to seeing your work.